plus 3.
Plus 3.
So same way if we'll take negative ions. So examples, can anyone say? One is chlorine. So what is the valency of chlorine? 2, 8, 7. So valency is
-1.
-1.
Understanding. So same way if we'll take oxygen. 2, 6. Yes or no? So we'll take valency of oxygen 2, 6. So then we can, what will happen?
-2.
Electronic configuration. So it will become -2 valency. Same way if we take nitrogen 2, 5. So valency is what? -3.
-3.
So these are called as negative electrovalency and these are called as what? Positive electrovalency. Understand everybody? So this is what you have to understand. So now after this is what we used to call as by the whatever it is gain or loss by covalent compounds, ionic compounds or electrovalent compounds is only called as electrovalency. So now if you'll understand this, then as we know, what is the second term? Covalency. So everybody keep heading. Covalency. So covalency is formed by whom? Only covalent compounds. Covalent compounds. So covalent compounds, is it any donating and receiving electrons? Please?
No, sir.
No, only what it is present in covalent compounds.
Non-metals and non-metals.
No. So that is what you have to understand. So by sharing electrons, they used to try to form, trying to get the stable in nature. That is what we used to say covalency. So please write. In the formation of covalent compounds also used to call it as what?
Molecular compound.
Molecular compound.
Okay, right. In the formation of covalent compounds or molecular compounds, the number of electrons shared by one atom. The number of electrons shared by one atom of an element, shared we can say, of an element, to achieve the nearest inert gas electronic configuration, the number of electrons shared by one atom of an element, shared by one atom of an element to achieve the nearest inert gas electronic configuration, is known as its covalency. So how many electrons they can share? They can share 1 electron, they can share 2 electrons, they can share 3 electrons, they can share more than that. That's all. So maximum 4 electrons they can. So its valency will be. So now let us see covalency example. Have you understand, guys? Everybody? So now covalency of hydrogen. So hydrogen is a diatomic molecule. Is it yes or no? Please respond. Hydrogen is a diatomic molecule. So if you try to keep one hydrogen atom, so that it cannot survive. Understand? It won't be stable in nature. So what is happening? It won't be stable in nature. So that what is happening always? You might be see it is hydrogen atom. So hydrogen atom not unstable in nature. So it will combine with one more hydrogen. Then it will form what? Hydrogen molecule. Understanding? So hydrogen molecule, then only it will become stable in nature. So this is what we can say. First one, covalency of hydrogen. Covalency of hydrogen. How many electrons? Covalency of hydrogen. 1 electron or 2 electron? Covalency of hydrogen, 1 electron or 2 electron, guys?
2 electrons.
1 electron. Understanding? Because only 1 electron it can share, correct? Nobody will respond. So hydrogen basically having 1 electron. Yes or no? Please respond.
Yes, sir.
Another hydrogen also having 1 electron, so that both they will combine together so that to become stable in nature. So both they will feel that both are having 2 electrons, so that they will become stable in nature. Have you noticed it? Understand everyone? That is what. So what is the covalency of hydrogen? Covalency of hydrogen is one electron sharing. Understand? That is one electron sharing. Next, if you take, go for next, covalency of chlorine. Covalency of chlorine also check it. Covalency of chlorine, how much it will come? Covalency of chlorine. Covalency of chlorine also. We cannot write Cl2. Wherever you are writing Cl2 will write, because chlorine one atom alone cannot stay alone, cannot survive, because what is the valency? 2, 8, 7. Yes or no? So another another chlorine also will combine 2, 8, 7. Yes or no? So they needs one electron. Yes or no?
Yes, sir.
Yes, so that they will start forming and they will make chlorine molecule and they will share one electron each. Understanding? So chlorine has 7 electrons in its outermost shell. So it can share its one electron with one electron of another atom to achieve 8 electrons in a gas electron arrangement. So since each chlorine atom shares one electron, we can say it's just valency or covalency of chlorine is how much? 1. Understand everyone? So now if you draw the structure, so what will come, guys? You should speak. So 2 electrons. Is it yes or no, Pradosh? So now second
Yes,
cell,
sir.
how many?
Yes, sir.
Second cell, how many?
8 electrons.
2, 3, 4, 5, 6, 7, and 8. Let me take. Now next cell, how many? Next cell,
7.
they are having 7. So basically, if it wants to become stable, then how many electrons in its nature? It is having
8 electrons.
3, 7. Correct or not? So now here one more chlorine atom is there, 8 electrons. So that what is happening? So you can notice it 1, 2, 3, 4, 5, 6, 7, 8. So this is 1 and 2. Now here, this is the sharing electron. Let me imagine. So remaining 3, 4, 5, and 6 and 7. Okay. Now they will combine together. How they will combine? Let me draw like this. The chlorine will combine, so they will share one electron. So now you can notice it remaining how many electrons for this? 6 electrons. Yes or no? 3, 4, 5, 6. 6, now 7, 8. This electron also what? 1, 2, 3, 4, 5, 6, and 7. You can see. Okay, this is not. So 1, 2, 3, 4, 5, 6, 7, 8. So this is what? Chlorine. So they will share and they will form chlorine molecule. So here also one electron they are sharing each. So that we can say this covalency is how much? Chlorine covalency is what? 1. Understand? So this is all will shows by non-metals only, because they are not all stable in nature, and most of the non-metals are gases. Most of the non-metals are what? Gases. So they are always diatomic molecules. What they are, guys? Diatomic molecules means single atom cannot survive. So more than one atom, it should be together, then only it will be existed. So that is why we can say diatomic, triatomic, monoatomic, like that we can say. Next, you can take covalency of oxygen. Covalency of oxygen, how? Like this only. Can anybody say? Covalency of oxygen, 2 electrons. Yes or no? So covalency of oxygen, we can say what? One oxygen molecule, 2, 8, correct, 2, 6. Yes or no?
2, 6.
Yes, 2, 6. Another atom, how many? Another 2, 6 only. So oxygen. So that how many electrons they can share? They can share 2 electrons.
2 electrons.
Inert gas electronic configuration. So I can say covalency of oxygen is how much? Covalency of oxygen, which is equals to 2. So that is why its valency is how much? Its valency is what? 2. But usually we can say -2. Yes or no? But it is sharing, so we cannot say it is plus or minus. Okay, everybody. We can say it's covalency.
Yes,
Next, covalency of nitrogen. If we'll take covalency of nitrogen, what? Covalency of nitrogen. So covalency of nitrogen N2. So
2,5.
N nitrogen molecule 2, 5. Another N nitrogen atom 2, 5. So they will share how many electrons to get stable in nature? 3 electrons. Understand? So its covalency is how much? Its covalency is how much? 3 we can say. That is what. So now same way if we'll take next covalency of carbon. You can take what is the covalency of carbon? Anyone? Covalency of carbon.
4.
4, sir.
So covalency of carbon you can take, but usually carbon can exist alone. Understand? So it will combine with the another non-metals. Understand? So carbon even can exist alone itself. So it will combine with the another. It is not combined with another carbon. Do you understand? Carbon alone it is 4. So 4 means it cannot share with another carbon. So C2 won't come. Understand everybody? Tamil Selvan, Adarshan? C2 won't come. So what will happen? It will react with some other thing. For example, if we take carbon, how many electrons are there in a valency cell? 4 electrons. Yes or no? 2, 4. Yes. So it will combine with 4 hydrogens. So it is also used to called as covalency only. Have you seen 4 hydrogens? So it will form CH4. So we can say covalency of carbon, which is equals to 4. Okay, but carbon alone cannot form 4 bonds. If what? Carbon also can form in molecular compounds. For example, if you take 10th class, we'll study carbon compounds on separate chapter. So here, carbon is having a property called as self-linking. So it can form like this also. Purima, what I'm saying, are you understanding? So like every carbon will combine with another carbon. So this is only we used to say, understand, it can combine, keep on combining like this. This is what branched chains of carbon. So but everywhere, what is the covalency of carbon? Covalency of carbon is 4, whatever it. Understand? So it can combine with the chlorine or carbon itself or hydrogen or whatever it is, any other non-metal. Is it carbon will react with any metal? Is it carbon will react with any metal? That is what my question.
No, sir.
No,
No, sir.
Carbon always will react with the other non-metals only. It will never react with the any metal. That is what it is. So always the covalency of carbon is how much? It is how much, guys? 4 it is. You have to take it. So this is what you might be understand what is electrovalency and covalency. So now this is all about it. In tomorrow's class, we'll finish this chapter almost. That is what isotopes, and as well as next one is what? Isobars. So isobars, and before that something I want to say, that is what atomic mass, fractional atomic masses and all something I will say. So that is only isobars it will come, isotopes, and after that radioactive isotopes also it is there. That is also I will explain. That is only uranium 269 and all. So after that we will end this chapter, because next week only we have exam, correct? So hardly maybe tomorrow we'll finish, or if not day after tomorrow. So this I will leave. We'll meet tomorrow. Thank you everybody. Bye.
Thank you, sir.